In this video, I'd like to go over a technique for finding the domain and range of functions using their graphs. Now, first of all, this is a function we had looked at in the past called f of x equals x. And the technique that I use for finding the domain of a function is to pick several points on the function itself. Now, these points can be totally arbitrary, but you want to pick a few. And now you want to trace them down to find their x coordinates. And for these ones that are negative, we'll trace them up until we've intersected those points with the x-axis. Now if we make a dot on the x-axis, this dot represents the input for those outputs. Every single x value is going to have an output somewhere on this graph. There's no x values that don't have outputs. And I'm also going to say that this shading could go on forever in the positive x direction and in the negative x direction. What I've sketched is the domain of the function. It's about projecting the function onto the x-axis and then stating those points as a set. You can do it in algebraic notation or interval notation. That's the domain of this function. Of course, this is a line that keeps going forever in the first quadrant and also into the third quadrant. Alright, that's finding the domain of it. Now we'd like to find the range. So what we want to do there is we want to take our points and project them onto the y-axis now. These are going to be our output values of the function. And as you can see, they will be everywhere in the positive y direction and the negative y direction. There's no y's that aren't represented here. And so our range is going to be from negative infinity to infinity. Or we can put it in interval notation. But this time we're talking about y values instead of x, because we're talking about the vertical values. Now the result we got from the graph should make sense if we think about the function as a machine and how we can put in any number on the left. And then we get out those same numbers on the right. So if you can put in any real number as your input, then it makes sense that you can get out any real number as your output too. Alright, this function is f of x equals the absolute value of x. Similar to f of x equals x, but notice that it doesn't continue into the third quadrant. It's reflected and it goes into the second quadrant instead. That's because negative output values aren't allowed. We can only get positive values or 0 out of this function. So let's use the method of just picking any points on the graph, and then we'll trace them down to the x-axis and then build a domain from that. Apparently you can plug in -6 and you can plug in -3. You could plug in 0 or 2 or 5 or 7. Any x values apparently are allowed. So put dots where your allowed inputs are. And keep in mind that these are not the only allowed inputs. We could have arbitrarily picked anything between those values. So this is a visual picture of our domain on the number line. And it's just a one-dimensional thing. It's on the x-axis, so these are x input values. And it could certainly go on forever in the positive direction and the negative direction. So this is our domain. X is between -infinity and infinity. Same domain as f of x equals x. What about the range though now? In order to find the range, we trace our points over to the y-axis to see what our output values are. We want to see what the allowed output values are. So we have an output value of 2. There's an output value of 3. There's a 5 and a 6 and a 7. We could have picked any points in this range here. Even 0 itself. And it could keep going forever into the positive y direction. When it comes to our range, though, notice that we don't get certain types of numbers. What outputs didn't we get? Like we have curve in quadrant 1 and quadrant 2, but we don't have any curve in quadrant 3 and 4. That means we don't have any negative outputs. An absolute value can never output a negative value. So that means our range is going to be from 0 to infinity. We can write that like this. We also want to include 0 as part of the possible outputs of that function. Like if we were to put in a 0, we would get out 0. In interval notation, this would be written like this: 0, infinity. 0 has a bracket with it because 0 is a possible output value. Now if we want to get creative here, we can draw the interval on the axis itself using a bracket and a parenthesis here, because it goes on forever, and kind of turn our heads sideways, and then it looks exactly like I've written it here in interval notation, but we're talking about y values now. If we look back at the machine explanation of the function, we want this to agree with what we found in the picture above. So if our function is f of x equals absolute value of x, and you were to plug in a -3, and you get out +3. Plug in a -2, you get out +2. So see, no matter what you plug in, you're never going to get a negative value out. You always get a positive or 0.